My name is Sam Skeet, and we are BME Capstone Team 25, or StarHeart Biometrics. Our team consists of me, Kristen Huber, Carly Espinoza, and Justin Irby. Our team is supported by our clinical and technical mentors, Dr. Kimia Syed Madani of NASA and David Hope of Data Robot. The issue that we are trying to solve is that NASA would like an integrative system that can record, monitor, detect, and predict cardiovascular parameters such as heart rate, blood pressure, EKG, and partial pressure of oxygen for astronauts in space. To do this, we are creating a software product that uses machine learning algorithms to monitor these parameters and warns the user operating the software if adverse cardiovascular events occur.
The rigors of space travel have many adverse effects on the human cardiovascular system. This can lead to arterial stiffness, comparable to 10 to 20 years of aging on even short missions, which can cause increased risk of chronic kidney disease, hypertension, or stroke, and leads to astronauts being 4 to 5 times more likely to develop cardiovascular disease than people who just stay on Earth.
Customer needs were developed based on on-ground applications as well as for members aboard the ISS and other missions. No matter the members aboard any mission or the ISS, individualized real-time data monitoring will be completed. Our primary metrics to monitor are the ECG, partial pressure of oxygen, and blood pressure for those on ground and aboard missions. Personnel at ground control will be notified of any adverse events as well as the individuals aboard the ISS or any missions. Design of the algorithms for the machine learning portion of this application was separated by direct real-time data and predictive modeling data. On direct real-time data, statistical analysis will be performed to determine if there is a cardiac event that needs to be reported to ground control or if simply the data can be sent to ground control and the astronauts on board the ISS or any missions. Predictive modeling will be done by a variety of methods, including linear regression as one of our options, on data that might not be able to be acquired in real time or might need to predict changes that are happening as we learn more and more about space travel and the effects it has on the cardiovascular system. Either way, data will be reported to those on board the mission or ISS and ground control, and both parties will be able to see alerts of any adverse cardiac events.
The concept we have in mind so far for our user interface is for the user to log in with their personalized credentials to ensure security, then to select which type of data they would like to see. Here is an example output of the partial pressure of oxygen, the EKG, as well as the blood pressure. After that, they can select a graph based on certain time points and which data they would like to see how the data has changed over time and evaluate from there. Also, these are examples of how the alerts will be given. As our team moves forward, our next steps include using models to prove the viability of our product, to construct the code, and to reach out to experts for advice on our pricing of our product.